All right, students, and welcome back to the Dr. J Show with his great assistant, Miss Latasha Ovieson, who I will be quizzing while she's eating Chipotle. Latasha, what do you call a dog with no legs? It doesn't matter because he can't come when you call him anyway, so. Yeah, baby. Dark pet jokes coming your way. Mr. Cabezas will enjoy that joke, I'm sure. All right, so hopefully as you can see on the board, our next chapter, which we are combining with the previous one, is 1.6, describing pairs of angles. Hopefully you found last chapter as easy as I anticipate you will. This one is not much harder, okay? What you will learn in this chapter is how to identify complementary and supplementary angles and identify linear pairs and vertical angles. Very straightforward. So, as you can read here, it says pairs of angles have special relationships. The measurements of the angles or the positions of the angles in the pair determine their relationship. So, you've got this first, let me go over here first, make sure I don't miss anything. No, that's fine. All right. So the first thing to identify is called complementary angles. These are not two angles that complement one another. Oh, aren't you a cute? Oh, thank you. Don't be obtuse. No, those are not complementary angles. Complementary angles are two angles whose measures added together equal 90 degrees. And it is said that one is the complement of the other. So that's complementary. They add to 90 degrees. Okay? The other one, oh, they show it. Now look here. You've got two different ways that can happen, right? You've got two different pairs of angles. So these pair are connected to each other. They're called adjacent angles because they're right next to each other. Adjacent means right next to or beside. So 1 and 2 are complementary because when they're added together, they form this 90-degree angle. They are complementary. Over here, angle A and angle B are not adjacent. They're two separate angles hanging out in space. One is 20 degrees, one is 70 degrees. So when you put those together, 20 plus 70 is 90. That means angle A and angle B are complementary. A is a complement to B. The other term is supplementary, and if I were to ask you to guess what supplementary angles mean based on what we just learned, you would say 180 degrees. So supplementary angles are two positive angles whose measures have a sum of 180 degrees. Each angle is the supplement of the other. Okay, so again, you see this picture here. We've got two different representations. Here we have, if you remember, this is called a straight angle, which is 180 degrees. It's split by this ray into angle 3 and angle 4. So angle 3 and angle 4 are supplementary because added together, they're 180 degrees. Okay? And they are adjacent angles because they are right next to each other. Over here we have two separate angles hanging out in space, angle C and angle D. Angle C is 115, angle D is 65. When you add those together, that's 180 degrees. Those two angles are also supplementary even though they are not adjacent. Okay? And so here you see that term for adjacent angles. Complementary and supplementary angles can be adjacent or non-adjacent. Adjacent angles are two angles that share a common vertex and a side, but have no common interior points. So you can see here, this is a pair, angle 5 and angle 6 are a pair of supplementary angles. They share and create this 180-degree straight angle. They have a common side right here, okay, but they are adjacent to one another. Whereas on the other side, you see here, again, two angles that are non-adjacent angles. And they don't give us the measures, so we don't really know what that's about. Not a big deal. All right, so we are identifying pairs of angles. In this figure, in this example, it says name a pair of complementary angles, a pair of supplementary angles, and a pair of adjacent angles. So we look here. We want a pair of complementary, a pair of supplementary, and a pair of adjacent angles, okay? So we've got these three different angles we're talking about here. So let's start with complementary. We want two angles that when added together give you 90 degrees. Should not be hard to spot. Angle CAB is 37 degrees. Angle RST is 53 degrees. 37 plus 53 is 90. So those two angles are complementary. On the other hand, we've got angle CAD, which is 127, and angle RST is 53. When you add those together, that gives you 180 degrees. So those two angles are supplementary. And then finally, you can see here, angle BAC and CAD share the same common side of ray AC. They are adjacent angles. Their measure is unimportant. It's 164 degrees. That doesn't matter to anything. So they are non-complementary, non-supplementary, but they are adjacent. All right. So hoping they had given me an example for, okay. So now just a little bit of math. This math will be very, very easy. So given this description, please find the measure of angle 2. First of all, I would ask, I'm asking myself, Lisa,
Oh God.
what is the relationship between angle 1 and angle 2 in this picture?
They're complementary.
They are complementary. I compliment you on your answer. And thank you for your eye roll. Okay, and your head shake. That is a win-win. So as she said, they are complementary. They add up to 90 degrees. We know this because we have the box here identifying as a right angle. So if this is 62, we go 90 minus 62, we get 28 degrees. If we come down here, now we see a straight angle cut in half with this ray, not cut in half, but cut. And what that means is we have supplementary angles. If this is 47, we take 180, the whole thing, minus 47, and you get 133 degrees. Okay, so that's the simple math. Of course, they'll add algebra into it because why not? Might as well have fun and challenge yourself, right? So we have here monitoring progress. This is the time, Mr. Cabezas, whoever is my substitute, to pause and give the kids a chance to work these problems out on their whiteboards. Okay, and then I'll go back over them. So pause at this time. Great. All right. So number 1, name a pair of complementary angles, a pair of supplementary angles, and a pair of adjacent angles. Okay, start with complementary again. Complementary meaning 90 degrees. Okay, so if you look here, I've got an angle that's 41 degrees, and another angle is 49 degrees. Quick mental math, which I'm sure all of you are doing right now. 41 and 49 is 90. So if you were to identify those angles, it would be angle FGK and angle GKL. Those are your complementary angles. Now your supplementary angles, again, we're looking for angles that when added together give you 180 degrees. So with some mental math here, I see 131 and 49. Added together gives me 180. So my supplementary angles are HGK and GKL. And finally, adjacent angles, two angles that share a common side. I see right here this common segment GK, splits these two angles. So my angles FGK and HGK are my adjacent angles. They're summed together is 172 degrees, so that doesn't matter, but they are adjacent. Easy. Real life application. When viewed from the side, the frame of a ball return net forms a pair of supplementary angles with the ground. Find the measure of angle BCE and the measure of ECD. Okay? This reminds me, I used to play softball back in the day. And so just so I would get, warmed up and get my target on, I bought myself a return net where you throw a softball to it and it would kick it back to you to work on your catch and your throw. So I was outside my front yard doing that one day, and my little dog, my little Shih Tzu, the one that I, did what I did to for all you know, my dog story. She was older at this time, a little decrepit, and so she was hanging out with me in the yard. And I wasn't paying good enough attention to where she actually was at, or I was trusting my aim way too much. And so I was chucking that softball, getting it right back from the net, and I threw it once just a little wild. and just a little too far to the side, missed the whole net structure completely, and struck my poor little dog in the back of the head. And she went into a seizure. And I thought I had killed her, was holding her in my arms, like, please, please, be better. I don't want to have to spend money at a veterinarian bill. Please get better. And she did recover that evening, thankfully, with only minor brain damage. The brain damage I think I'm joking about, she did survive and seemed fine, fortunately. So, you know,
Oh my god.
the lesson of the story is being a pet in the Johnson household, probably not the best thing. And I digress. Back to the math at hand. All right. So we have this soccer return to soccer. Why waste time on soccer? But anyway, that's a whole different story. All right. It said to us in this problem that this is a pair of supplementary angles. If you recall, that means 180 degrees. I'm going to yell at Latasha, who is over here just yawning to death. This is the most exciting stuff you could possibly want to hear. I know I'm kidding. All right. I'll go over to the board and work this out really quick. So you've got these two angles. You've got angle BCE, the angle of the ball return, adding a level to the ground over here of ECD. So these two angles together are supplementary, which means they equal 180 degrees. A very quick and easy equation to solve. Right, so here's angle 1, here's angle 2. Add together are supplementary, 180 degrees. 5x plus 10 equals 180. 5x equals 170. X equals 34. Double checking, make sure. Yeah, all right. So x is 34, plug that back in. I'll start to the easy side here. 34 plus 2 is 36 degrees. Subtract that from 180, and this would be 144. Okay? All right. Here we are again. Something for you all to work on. So again, at this point, whoever's in charge of the video, pause at this time. And we're back. All right. So in this example, angle L, M, N, and PQ are our complementary angles. And it gives us what they equal to, or algebraically solve for both those angles. Well, that's easy enough. If they're complementary, that means they add up to 90 degrees. Okay? This angle plus this angle are complementary. That equals 90. 13x minus 1 equals 90. 13x equals 91. Divided by 13, x equals 7. So plugging that back in, the first angle here, 4 times 7 is 28, minus 2 is 26 degrees, and then the other one, 9 times 7 is 63, plus 1 is 64 degrees. Okay, so 64 and 26 degrees are your angle measures. Easy math. You just need to have it memorized what complementary versus supplementary means. And if Latasha can memorize it, I'm confident the rest of you will have no issues whatsoever. Oh, I'm just joking. All right. Linear pairs and vertical angles. Another time for opportunity to write just some brief notes. We will be working with these. You're going to see vertical angles for a long time in geometry this semester. So please do not, but the concept is very simple. What you're going to do is you're going to overlook them, and I want you to avoid doing that. So we've already, a linear pair is an adjacent pair that forms a straight line. Okay? So two adjacent angles are a linear pair when their non-common sides are opposite rays. In other words, this is a straight angle formed by two angles. They are called a linear pair because they form a line. Easy. Linear pair form a line. Vertical angles. So over here with vertical angles, you got when two lines crisscross each other, as you can see, they form 4 different angles, 3, 4, 5, and 6. Okay? Angles opposite of each other are called vertical angles. So 3 is opposite 6. So those two angles are equal. Okay? Here, 4 and 5 are opposite, so those two angles are also equal. In addition, by the way, 4 and 6 are called a linear pair, what we just learned, because they form a line. 6 and 5 are linear, 3 and 5 are linear, and 4 and 6 are linear, okay? So, vertical angles are equal. So here, identifying our angle pairs. Identify all the linear pairs and all the vertical angles in the figure. All the linear pair and the vertical angles in the figure. So, please don't tell me that 1, 2, and 3 are a vertical pair. Why? Why are 1, 2, and 3 not a vertical pair? You know,
Are you asking me?
I am. Why are 1, 2, and 3 not a vertical pair?
Well, it can only be two numbers.
There
first
you
of
go.
all.
So smart.
I know.
That's our future attorney, Latasha Ovieson.
No.
Yes.
No.
Anywho, the answer she gave, if you didn't hear it, is by definition, I'm asking for a linear pair, which means two angles. 1, 2, and 3 are three angles. They do form a linear grouping, but they're not a linear pair. So the linear pairs are this: 1 and 4, and 4 and 5. Okay, this one sometimes you might not see right off, but 4 and 5 form this line. 1 and 4 form this line. Now, as far as vertical angles, at first, if this is your first time with this, it might seem a little confusing, but there are only one pair of vertical angles, and it is angle 1 and angle 5. They must form from two straight lines. 2 and 4 are not vertical. It looks kind of like they are, but this is the straight line, but then this one bends over here, so that is not vertical. Only 1 and 5 are vertical pair. Finding angle measures in a linear pair. This is so basic, I'm not even going to write it on the board. I'll just talk you through it. I'll pause here actually momentarily. You all should be able to calculate this. Give me the measure of both of those angles. Okay, those two angles form a linear pair, which means that they add together to get you 180. So you would go 5x plus x equals 180. 6x equals 180, right? And then so what that means is x equals 30. So this is 30, and this is 150. And together, they are 180. Easy. It's not really going to get much harder in this chapter. That's why I brought these two chapters together. All right, monitoring progress. Again, instructor, time to pause the video so that the kids can answer these questions. Okay, so go ahead and pause that now. All right, we're back. Number 6 says, do any of the numbered angles in the figure form a linear pair? Which angles are vertical angles? Explain your reasoning. Okay, so do any of the numbered angles in this form a linear pair? The answer is no. There are not two angles that add up to 180 degrees. There are 3 angles that do, but that's not a pair. That's a triplet. Okay? Which angles are vertical angles? Well, that's fairly easy to see. They're all straight lines, so 6 and 3 are vertical. 2 and 5 are vertical. Then 1 and 4 are vertical. Okay? 3 pair of vertical angles. No pair of linear pairs. So here it says the measure of an angle is twice the measure of its complement. Find the measure of each angle. This has nothing to do with that figure. Not related at all. This is an algebraic problem. Let me come over here. The measure of one angle of a complementary pair is twice that of the other angle. Right? So, one is x, the other one is twice that, and they're complementary. The measure of one angle is twice that of the other angle of its complement. Find the measure. 3x equals 90, x equals 30. So you've got angle 30 and angle 60. Two angles form a linear pair. The measure of one angle is 1/2 times the measure of the other angle. Find the measure of each angle. So I've got one angle that's x, the other one is, what did it say? 1.5 times. I'm going to write that as a compound fraction, 3/2 x. It's 1.5 times the other one equals 180. It's a supplement. I'm going to leave it in fraction form. If you put it in decimal form, that's fine, but you're using a calculator, I'm not, and fractions are going to be easier for me to do this with. So I combine these together and I get 5 over 2x, 2.5x equals 180, multiplied by the reciprocal. X equals 5 here, 3, 36, 72. Okay, so one angle is 72. The other one is 1.5 times that, which is 108. Okay, 72 and 108, and to make sure we're correct, they should add up to 180, and they do. All right. Oh, this last thing, good. See, it didn't even get complicated at all. So this is good news. This is good stuff for you to learn. There are some things you can conclude from a diagram, and some things you cannot. For example, here are some things that you can conclude from the diagram below. Let's see. What I'm going to ask you is, what are you tempted to conclude here that you cannot? Okay? So think about that while we look at what you can conclude. All points are coplanar. Okay? You can assume that or conclude that based on the drawing. Points A, B, C are collinear, and B is between A and C. Line AC, ray BD, and ray BE intersect at point B. Okay, so everything you see here, this line, this ray, and this ray, you can conclude all touch at B because of the way that's drawn. And you can conclude angle DBE and EBC are adjacent angles, and ABC is a straight angle. Okay? So this angle DBE and angle EBC are adjacent angles. You could also say ABD and DBE are adjacent angles. That's fine as well. And we can conclude this is a straight angle. What do you think? Testing Latasha again. What can't you conclude? It looks like it is, Latasha, but you can't conclude it. Do you know what that is?
No.
You do. You're just missing it.
I'm tired.
You cannot conclude. Okay, this one is not what I was thinking of for you. You cannot conclude that AB and BC are equal. They look equal, right?
No, they don't.
The lengths look equal.
Really? Oh, the length?
Yeah, the length.
Aren't they even like the angle?
No. The length
of
of the length of these. You can't. These two look equal. These two segments, right? The length. But you can't conclude that because it doesn't have
the hash marks.
The hash marks or the tick marks, right? It has to have those, right? You can't conclude that. You also cannot conclude that DBE and EBC are equal measures. Okay, again, those look like they could be the same degree. It almost looks like this is forming a 45-degree angle, so this and this are equal. But you can't conclude that without the hash marks for the angle measure being equal. And then the other thing you cannot conclude, this is what I was hoping you were seeing, Latasha, is you cannot conclude that that's a right angle.
Oh.
It looks like a right angle, right? It does, but you can't conclude it. The point being here is, please don't trust your eyes in geometry. I said this to Latasha last year, around the same time when I come to determine what I think she would make a great, you know what, in your future.
Thank you.
Okay? But what is important about certain things is interpreting data and not going with what you think it should be. And that's what attorneys must do. They must interpret the law and what you can prove, not what you believe to be true, right? So, same thing in geometry. Only go with what you can prove. If it's not provable by what is here, you cannot conclude it. All right, so those are the things you can and can't conclude. That's just kind of a summation to we're going to talk about going forward. And that is, here they show, to get rid of those things you can't conclude, you have to have all of those marks added in there, and then you could conclude those things. Okay? So I believe that's the end of our chapter. We now head into our homework, which I will have assigned. So this video should be available to you to watch back if you need to go back over it. Share with your friends, neighbors, followers galore, so I can make millions of dollars with these amazing videos. Anyway, thanks guys. I will see you tomorrow.
You have to do it.
Oh.
Sign off.